Okay, so hi everyone, welcome to another pre-recorded video. So this is a requested pre-recorded video of everyone, how to balance chemical equations. So technically in here we are gonna discuss how to write and balance chemical equation, as well as the different types of chemical equation. Of course, let's start with the different types of chemical reactions before we proceed to the writing of chemical equations and balancing them. So that is always the sequence. You have to know first what is the type of chemical reaction that you are dealing with. And right after that, you write the chemical equation. Then right after that, you balance the equation. So we have four different types of chemical reactions, namely combination reaction, decomposition reaction, single replacement, and the double displacement. Please be very careful because in some cases, you might name single replacement as single displacement, okay? It is just single replacement because only one ion is transferred to another. Okay, you will see later why it is called replacement and not displacement. For double displacement, it is called displacement because the the two ions in a particular compound of two particular compounds actually displace, meaning nag-change sila ng place. So that's why it's called double displacement. So make sure not to interchange the two terms. Let's start with the combination reaction. So in the combination reaction, it is just simply the reaction of your reactant A to B, and that yields to A, B. So technically, you are just combining the two reactants. So a very good example here is the one that we have here as our problem. Write the balance reaction of hydrogen and oxygen gases. Okay, so may missing word lang dyan. Write the reaction, write the balance reaction of hydrogen and oxygen gases. So of course, you need to identify first what are your reactants. So in this case, we know that there is a reaction of hydrogen gas and oxygen gas. And remember, hydrogen gas as well as oxygen gas are all diatomic molecules. Please remember that all group 6 elements in the periodic table, iodine, bromine, oxygen, what else? All of the halogens are actually diatomic, meaning it cannot stand alone. It is not, it is existing in an elemental form, but it is unstable. That's why you need to make sure that it is diatomic so that it will become stable. Take, for example, oxygen. You cannot see O, okay, only an oxygen anywhere. Okay, you have to group it or you have to have it diatomically. So, magiging dalawang oxygen or the ozone itself. So, magkakaroon ka ng 3 oxygens in that case. So that is for hydrogen and oxygen. So we know that if you combine these two, of course, you will produce water. And where did I get water? All you have to do is to make sure that you ionized, okay? Parang i-change nyo every element here into its ion form. And your hydrogen is in group 1 of the periodic table, so it will take a positive 1 charge, while your oxygen is in group 6 and it will have a charge of 2 negative. So doing crisscross, you will have H2O, which is dihydrogen monoxide or water. So this is now your chemical equation. So just please make sure that you do understand the diatomic molecules, okay, and you memorize what are those elements na magiging diatomic molecules in nature. And of course, you have to identify whether it is a combination reaction or not. Bakit to combination reaction? Because you only have one element involved, and that is hydrogen. Okay, even if there are 2 hydrogens here, it is just the same element. So technically, they will just actually combine with, this hydrogen here will actually combine to your oxygen for you to produce a dihydrogen monoxide. Now, of course, this is not the final answer because you were asked what is the balance reaction. So in solving for the balanced chemical equation, of course, you need to write down first all the elements, okay, that are in the reactant side. We call this left side as the reactant side and the right side are your products. And you read the arrow, not arrow, but you read it as yields 2. Okay, it means that it will produce the following. So that would be water in this case because you only have one product. So you list down all the elements that are present in your reactant side, and that is hydrogen and oxygen. List down all the elements that are in your product side, and that is hydrogen and oxygen as well. Then determine how many atoms are there. I'm talking about atoms, not number of moles. Okay, you might get confused because take for example, if you have 2H2, this 2 here is actually the number of moles, okay? And this part over here is actually the subscript. It means that there are 2 hydrogen involved. And this 2 here means that you have 2 moles of that diatomic molecule hydrogen. Okay, so this is moles, this is atom. So if you were asked how many atoms of hydrogen are here and you know that the subscript is 2, then definitely you have 2 atoms of hydrogen. Same with your oxygen, which is also 2. In the right side, in the product side, you only have two atoms of hydrogen and you only have 1 oxygen atom, and that is this part over here. And that is the problem because in your reactant side, you have 2 oxygen atoms, and in your product side, you have 1 atom of oxygen only. So that means that the equation is not balanced. Why are we balancing? Because we are following the third law of chemistry, which is the law of the conservation of mass. That means that what you react should be produced. That means that if you have this particular number of carbon in your reactant side, that should also be the carbon in your right side. It may not be the same element, or no, sorry, it may not be the same compound anymore, but make sure that that particular carbon is still existing. Okay, dapat nandoon pa rin po siya. Hindi po siya mawawala. Because remember, energy, atoms, matter can neither be created nor destroyed. Hindi siya pwedeng mawala. So in this case, if you will be having this chemical equation, that means may nawalang isang oxygen, and hindi yun pwede. Okay, following the law of conservation of mass, you need to make sure that you have 2 oxygen. So you have to multiply it here by 2. Okay, this numerical coefficient that we have here, it has a distributive property. Remember, in mathematics, you have to distribute the number of your numerical coefficient to the subscript. That is the same to your that is the same to chemistry. So you have to distribute this 2 here to the subscript of your hydrogen and to the subscript of your oxygen as well. And that is 2. So that means your hydrogen here will have 4 atoms in total, while your oxygen now will have 2. So as you can see, your oxygens are equal. Unfortunately, your hydrogen now become 4. So that means it's not equal anymore. So you have to change as well your hydrogen in the left side, changing 2 into 2. So you have to add a 2 numerical coefficient here, okay, in the hydrogen side for you to have 4 atoms of hydrogen. Now let's check if our answer is correct. How many atoms are there in your hydrogen in the reactant side? So you have 2 times 2, that's 4. How about in the product side? That's 2 times 2, and that is 4. How about the oxygen in the reactant side? You have 2. While in your product side, you have 2 times 1, and that is 2. So that means our equation is already balanced. So the final answer would be, there should be 2 moles of your hydrogen gas reacting to 1 mole of oxygen gas. Pag walang sinulat na numerical coefficient before a chemical equation, before a compound, okay, before a reactant or a product, that means that the numerical coefficient is 1. No need to write that one. It's the same rule applies in math. You don't have to write the base 1 anymore, the exponent 1 anymore, the numerical coefficient 1 anymore, because it's already understood. So same here. And you have now O2, and of course that gives you or leads you to 2 moles of water. So what does it mean? You need 2 moles of your hydrogen gas and 1 mole of your oxygen gas for you to produce 2 moles of water. So that is how are you going to answer combination reaction. So we're done discussing the combination reaction. So here's another type of chemical reaction, and this is called decomposition reaction. Decomposition reaction is actually the total opposite of your combination reaction, because in here, if in combination reaction you have 2 reactants and you're gonna produce 1 product because you just combine the 2 products, in decomposition reaction, it's actually the kabaliktaran. meaning you have only one reactant and you will have two products. You are decomposing a certain compound, producing two particular products. So let's use the one that we have a while ago in the combination reaction, water. So let's have the decomposition of water. So in this problem, you are asked, write the balanced chemical equation of the decomposition of water. So that means that your water here was decomposing, and that means that your water is actually a reactant. So to decompose water, we know that it would actually produce or will yields to hydrogen gas and oxygen gas. Again, remember, hydrogen and oxygen are diatomic molecules. So it will have a subscript of 2. So this is the chemical equation of, excuse me, that's the chemical equation of the decomposition of water. And of course, that's not yet the final answer because you were asked what is the balanced chemical equation. So you have to have the balance equation first. So in the balance equation, of course, you need to write down again the reaction. So you have water that yields to hydrogen gas and oxygen gas. Next is to determine the elements that are in your reactant side and in your product side. So in this case, you have 2 atoms of your hydrogen and you have 1 atom of your oxygen. Same applies to your product side. You have to identify it again. So you have 2 hydrogen and you have 2 oxygen. So to make sure that this would balance the equation, as you can see, your oxygen is not equal to that of the oxygen in the product side. So you have to multiply, or you have to produce a numerical coefficient here of 2. So that distributing this 2 here in 1, you will now have 2 atoms of your oxygen. Distributing 2 to the atoms of your hydrogen that is present here, you will produce 4 hydrogen atoms. And as you can see, it's not equal anymore in your product side. So this 2 here, the 2 atoms of your hydrogen should be multiplied to a 2 so that you will have 4 atoms of hydrogen in the product side. And now it is already balanced. So as you can see, it's just the same process as the one that we have a while ago for the combination reaction. The only difference is we have different reactants and we have different products, because in here, this is the composition reaction talking. A while ago, it was combination reaction. So to write on the balanced chemical equation, that would be 2 water will be needed for you to decompose. You have to decompose 2 moles of your water for you to produce 1 mole of your hydrogen gas. Sorry, 2 moles of your hydrogen gas and 1 mole of your oxygen gas. Okay, so this is now already balanced. So just remember that combination and decomposition reaction is like an antonym. Totally magkaiba lang sila in terms of the positioning of the compounds. So the combination is when you produce something, the composition is when you segregate something. So that's the concept. So that is the composition reaction. Let's proceed to the next type of chemical equation. Okay, let's proceed to the third type of chemical reaction, which is the single replacement. So you have there the word replacement. So please make sure that you remember that word replace, because later on I will explain why are we using the word replace and not displacement in this case. And of course, please do remember that if you're going to write a chemical reaction, a chemical formula, you have to write first the cation before writing the anion. This is specifically if that is ionic compound. So you need to write first the cation before the anion. So take for example in our problem here, you have the sodium chloride. So we know that we have 2 ions involved in this chemical formula, and that is the sodium ion and the chloride ion. So your cation, which is the Na positive because sodium is actually in group 1, that's why it has a charge of positive 1. For chlorine is in group 7, so it will have a charge of negative. Okay, and so you will have sodium chloride. as your chemical formula for this case. So what did you write first? It's actually the cation. So laging ganyan, especially in ionic compounds, laging dapat mauuna si cation in writing the equation. So bakit ko kayo na-review niyan? Kasi it's very important later on as we write the equation under single replacement. So in this case, write the balanced chemical equation. Let me erase it first. Equation of the reaction of sodium chloride and zinc. So sodium chloride, we know that is NaCl, and zinc, which is a metal. Okay, remember that zinc is actually a metal, so it has a tendency to become a cation. Okay, so magiging Zn2 positive po siya, while your NaCl will have Na positive and Cl negative. So, in this case, we call this single replacement because the single part here, which is the second reactant, will replace, okay, if this is a cation, it will replace the cation in the first reactant, which is your sodium. Okay, so in another type of single replacement, if this is an anion, it will replace the anion part, which will be later in the next slide. But in this case, since this is a cation, it will replace the cation in this particular compound, in this binary compound. When you say binary compound, that means that the compound consists of two types of elements. And in this case, it's sodium and chlorine. So, alin ang papalitan ni zinc? It will be the chlorine. So, you will now have zinc chloride. So, that would be ZnCl2 because zinc has a positive 2 charge. Plus, of course, the Na. So, as you can see, the zinc now, which is the cation, the single cation in the reactant side, was paired to the chlorine, which is the anion of the first reactant. While your sodium now, siya na yung mag-isa. So, technically, zinc here replace the part of your sodium in sodium chloride. So that's why it's called replacement, because you are replacing something with another. And ngayon, nawala na ngayon si sodium. So you will have zinc chloride. Hindi naman nawala. Magiging single na siya. Okay? So it is a single replacement because you are replacing one part of the compound, which is in this case, cation. So you will have the chemical formula of, so the chemical equation rather, is NaCl plus zinc yields to zinc chloride and sodium. And the next step is, of course, to have your balance equation because that is one asked in the problem. What is the balanced chemical equation? And of course, to balance the chemical equation, you need to write down all the elements that are involved in the reactant side and in the product side. Okay, make sure na magkatapat para hindi kayo maguluhan. So your Na here, how many atoms are there in your sodium? It's only 1. Chlorine has only 1 and zinc has only 1 as well. Your sodium in the right side, which is your product side, is 1. Your zinc is, your chlorine is 2 because you have 2 here, and you have 1 for your zinc. So as you can see, it's not equal because your chlorine in the reactant side is 1 and the chlorine in the product side is 2. So you need to balance that one. So how are you going to balance that? You have to multiply this part over here with 2 so that by distributive property, your chlorine will have 2 atoms. Unfortunately, because of the addition of 2 in the sodium chloride, mababago rin yung number of atoms ni sodium. It will now become 2 as well. Well, in their product side, isa lang siya. So you have to make sure that this one will become 2. So you need to add 2 here in the moles of your sodium, and now you have 2. So as you can see, you have 2 sodium ion in your reactant side. You have 2 in the product side. So we're cleared with the sodium. For chlorine, you have 2 atoms in the reactant side and you also have 2 in the product side. So cleared na rin si chlorine. Next is the zinc. You only have 1 in the reactant side and you also have 1 in the product side. So that means that the equation is already balanced. So what is your final answer? That means that you need 2 moles of your sodium chloride reacting with 1 mole of zinc. That will yields to 1 mole of, that will yield to zinc chloride, 1 mole of zinc chloride, and 2 moles of your sodium. Then, of course, you box your final answer because this is now the answer to this problem. So remember, your zinc here is a cation. That's why it replaces the cation, which is the sodium. How about if you have an anion? Let's have this one. This is another type of single replacement wherein the involved single type of element is actually an anion. It's a non-metal. So let's write it first. Write the balance equation of the reaction of magnesium chloride. So you have Mg, and magnesium is actually in group 2 of the periodic table, so it will have a positive 2 charge. So you have magnesium chloride, that is MgCl2. Chlorine is in group 7, it has a charge of negative 1. Plus iodine, and iodine is in group 7 as well. It's a halogen, so that's why it will have a diatomic molecule. So that would be I2. That yields 2. So this is the time now to determine which part, okay, ang papalitan ni iodine. Iodine in nature is actually a non-metal. So that means it will become an anion. So the charge would be I negative. For here, you will have magnesium 2 positive and you have Cl negative. So ano ngayon ang papalitan ni chlorine? Because it is a non-metal and it is an anion, it will replace the anion in this particular reactant, and that is chlorine. So they will just exchange, they will just be replaced. So you will now have magnesium iodide, okay, MgI2, plus, of course, the chlorine, which is diatomic, that's why it should be Cl2. And there, that is now your chemical equation. Now, let's have the balance equation. Okay, remember what we have here? We replace the anion of the first reactant, okay? Si chlorine, kasi anion in nature si sodium. Si iodine. So, ibig sabihin, kung ano yung nature ng single na element, okay, in the reactant side, yun yung papalitan niya dun sa first reactant. So, if the nature of the element is a non-metal, may tendency siyang maging anion. So, ang papalitan niya dun sa kabila is the anion. If the nature of the element is a metal, okay, so that means magiging cation siya, papalitan niya ngayon yung cation sa kabila. So, that is how single replacement work. Hindi pwede na si anion, papalitan niya si cation. So, there's no in anion part unless it is unless it is equivalent bond or equivalent compound. In this case, we are dealing with ionic bonding. Okay, so let's proceed to the balancing equation. So you have MgCl2 plus the iodine, and you have the Mg, magnesium iodide, plus chlorine. So in this case po, you have to write down again first the elements that are involved, that is Mg, Cl, and I. Count the number of atoms that are in the reactants and product side. So you have 1, 2, and 2. In the product side, you also have 1. Then you have 2 chlorine, you have 2 iodine. So as you can see, the equation is already balanced. So may mga cases na ganon na you don't have to put effort in it because it's already balanced. So in this case, the equation that we have is already balanced. So no need to add some numerical coefficients. So that means that you need 1 mole of your magnesium chloride and 1 mole of iodine, okay, diatomic iodine, for you to produce a magnesium iodide and the chlorine, the diatomic chlorine. Okay, so that is the single replacement. So 2 types of single replacement. It depends on the type of the compound, or type of the element rather, if that is a non-metal or if it is a metal or non-metal. So that is single replacement. Let's proceed to the last part, which is the double displacement. So in double displacement, there is an interchange of 2 particular ions. Okay, so that's why it's called displacement. Parang na-displace lang sila. Parang kumbaga ganon. Kanina, you change something, you replace something. So that's why it's replacement. Now for double displacement, let's have this example. Write the balanced chemical equation of the reaction of sodium sulfate and calcium chloride. So in writing the chemical equation, of course, you need to make sure you write first the cation. So it would be sodium and sulfate. Remember, sulfate is SO4, 2 negative. For your sulfite, that would be SO3, 2 negative. So by doing crisscross, you know now that your sodium will have a subscript of 2 and you have now SO4. Plus the calcium chloride. Calcium is in group 2, so it will have a positive 2 charge. By crisscrossing, you have now CaCl2. Now, where is double displacement happening here? So, para mas clear sa inyo, and if you're still starting here, you have to be very careful. So, you have to write first the ions. So, you dissociate everything. Paghiwalayin mo yung mga ions involved in the compound. So, in this case, you have sodium sulfate. So, you change these into ions, and that would be Na positive because sodium is in group 1. And you have SO4, 2 negative, which is the polyatomic ion sulfate. And of course, you have Ca2 positive. Calcium is in group 2. Chlorine is in group 7. So you have Cl negative. So where is now the double displacement? The double displacement will happen by having your cation in the first reactant, okay, combining with the anion of the second reactant. Again, it's the cation of the first to the anion of the second. The cation of the second to the anion of the first. So, you just have to displace them. Parang mag-change lang sila ng partner. So, you now have sodium chloride plus calcium sulfate. So, remember, calcium and sulfate has a positive 2 and negative 2 charges respectively. So, that means you could actually cancel out the 2 or the charge of the of both ions. That's why you have CaSO4 only. Okay, so that is now your chemical equation. Again, you react the cation of your first to the anion of your second reactant. You react the cation of the second reactant to the anion of the first reactant. So that's why you have sodium chloride and you have calcium sulfate. If you're familiar with FOIL method in mathematics, this is actually the outer inner. Okay, so you just combine the outer and the inner. And of course, wag na wag kakalimutan to write down first the cation. Hindi pwedeng maging SO4, Ca yan. That's incorrect. You have to write first cation. Again, cation muna. So you now have the chemical equation. Let's proceed now to the balance equation. So for the balanced chemical equation, of course, you now have Na2SO4 plus the calcium chloride that yields to NaCl plus calcium sulfate. Okay, now write down all the elements that are in the reactant side. That's Na, S, O, Ca, and Cl. In this one, you have also Na, S, O, Ca, Cl. So next part is to compute or to count all the atoms that are in the reactant side. How many sodium? You have 2. On the product side, you only have 1. For your sulfur, you have 1 here, and you also have 1 in the other side. For your oxygen, you have 4, and you also have 4 in the right side. Calcium is 1. Calcium in the right side is also 1. Chlorine here is 2, and your chlorine as well here is 2. So you have equal sulfur, oxygen, calcium, and chlorine atoms. The only difference is your sodium. So you have to multiply this one by 2. Okay, sorry, chlorine is only 1 here. Sorry. So you have to multiply this part here by 2 so that you will now have 2 chlorine. 2 sodium. And since it's already equal, the next step is to have a complete and an equal number of chlorine atoms. In the reactant side, it's 2, so dapat 2 rin sa kabila. And since nag-add ka na ng 2 sa sodium chloride, it will now have a distributive property, so that means you have now 2 chlorine atoms. So you now have a balance equation wherein sodium in both sides are 2 atoms. Sulfur is 1, oxygen is 4, calcium is 1, and chlorine is 2. So that is now the balanced chemical equation. Now, there are also cases wherein if you master balancing equation, actually there's no rule in, or there's no particular steps in writing, in balancing chemical equations. Wala talaga siyang rule. It's actually a trial and error process. But as you go along, as you practice yourself in balancing equations and medyo marami-rami ka nang masosolve and marami-rami ka nang mababalance, you will actually find yourself having a parang style on how are you going to balance everything. Sa akin, I actually group everything according to the ions. So, pwedeng, ang gawin nyo dito, i-group nyo si sulfur na nandyan, i-group nyo si sulfur na nandyan. Just make sure na pareho sila ng number. And since equal na sila, so si SO4 ay okay na. Si SO rather. So, equal na si SO. Something like that. So, you will actually get a lot of style, or may marirealize kayong mas mabilis na process. So, it will just take you practice. So, please, if you have problems in the balancing chemical equations, there are a lot of worksheets in the internet available in Google that actually has already answers, worksheets with answers. So, you search, then you practice yourself at home, because chemical equation or balancing chemical equation is one of the foundation in your general chemistry, and this will be widely used as you go along with the different fields of chem, especially in your Gen Chem 2 next year. So that would be all. That would be for the double displacement. So that is the last topic in this pre-recorded video, and that would be the end of this pre-recorded video. So this is again balancing equation. So if you have questions or you still have problems with regards to balancing equation, just please don't hesitate to inform me. Just like what one of my student did, na nag-request talaga siya kasi he cannot follow. So it's okay. So that's why we have this one. And I hope that this will help you guys. What else? If you have questions, just message me in our MS Teams, and see you in our synchronous discussion. This is Miss Arlie, and goodbye everyone.